So the second video that we're going to take a look at today for transformations is just this one. We're going to transform the log base 2 function. So we have a couple different things that we need to look at, and I want to build review in here. So my parent function is y equals the log base 2 of x. All right, so let's bring in some technology, shall we? Okay, let me blow this up. There's the log base 2 of x. Notice that this, for the parent function, its domain is all positive real numbers. Its range is all real numbers. And it has a vertical asymptote at x equals 0. Now, we had no vertical translation, but we're still going to look at this. Now I'm going to subtract 4 on the inside. Notice I'm just going to start pulling this. It's going to the right. So let's take this back to 4. Notice the distance from this x-intercept to this x-intercept is 4. This distance is 4. This distance is 4. So to move the mapping's x-coordinate from the pre-image is the parent right here where you began, to the image where you end, you moved it 4 to the right. So you would add 4 to the x-coordinates. Notice the new vertical asymptote is x equals 4. Now let me pull this back to, oops, I'm going to get that back to 0 because we didn't have anything inside. No, just 0. Okay. Now, we were subtracting 4. Okay. Oops. Okay. Now notice 1, 2, 3, 4. 1, 2, 3, 4. Every ordered pair is shifted 4 units up. Now, if I, oops, notice it's the same behavior as before. If I would have added or subtracted a negative, which is adding a positive, I would go downwards in my translation. All right. Mr. Isaac, you don't have the nice points. Well, I wanted to build in some review. You know that the inverse function of this is y equals 2 to the x. So I'm going to use this to get my points. Okay. 2 to the minus 2, 1/4. 1/2, 1, 2, 4. The domain is all reals. The range, y is positive, and we have a horizontal asymptote, y is nothing. To go from this function to its inverse, which is right here, and this is the parent function. The mapping says take your ordered pair and interchange your domain and range. So my range becomes my domain. My domain becomes my range. Because if you think about it, now hold on here, let me get this copied down. A logarithm is an exponent. Well, here are my exponents, and my exponents live right there, so that should be my outputs. Okay, now, if you look here, we only translated it 4 up, so I copy the x's, and I add 4 to the y's. So I take my table above, this table, I copy all my x's, 1/4, 1/2, oops, I forgot, 1, 2, 4. Now for my y's, I'm going to add 4, so 4 plus negative 2 is 2. Negative 1 plus 4 is 3. 0 plus, oops, wait a second, 0 plus 4 is 4. 1 plus 4 is 5. And 5 plus 2 is 6. So here are my ordered pairs. My domain. Oh, look, x's are left alone. My range. Well, if I add 4 to any real number, it's still a real number, so it's still all reals. My vertical line, I have to add 4 to it, so it's x equals 4. Boom. It's done.